Helen, good day to you. So I'm going to run through a C++ actor class and explain why it's necessary and set up the way it is. So to really simplify how a game works compared to other programs, a game has a frame. So every single frame, the computer game is cycling through every single value within the game world and updating it. And we often end up using a lot of object-oriented programming because we want to be succinct and controlled in how we cycle through all these objects, and we want to spawn and destroy and add new actors into the game. And an actor could be anything, but the easiest way to think of it, the starting point, is to think of an enemy. Now, if we let the CPU run as fast as it could, this would be fine back in the day, but on modern software, as we say, 60 frames per second is normal. So you can think if your computer game updates every 60 times a second and your enemy does 1 damage every frame, and you haven't divided that by seconds or something of the like, it's going to kill you instantly. It's going to be too fast. So Pac-Man could be unplayable on today's software if we didn't times the vectors and the changes of the values in it by a time delta. Now, every frame, every actor must be updated and take its action. So this is where it becomes highly object-oriented. Thinking about it in a high level manner, you're probably going to calculate your delta time at the top of your main loop. So you're going to have a while true in Python or something similar, and then you're going to pass it to every single object, every bullet, everything that needs to be refreshed, and call a function which usually programmers just call update for simplicity. When you're setting up this loop, you're going to enter into it once and probably not exit it until somebody calls quit or they lose. So you can see for SFML, and I think it's pretty similar for SDL, window is open is a value that goes and checks that somebody hasn't quit out of the window that you created. For something you might not have thought about is a player is still going to be an actor. Even the keyboard controls you're not going to handle hugely different. Now, you could do, but the reason to not do it this way and set up a bunch of booleans within the object called player, or the object that is representing your player, is because if you want to change the key controls at later points, you'd have to change the player value every single time. While if you create it so there is a bunch of true and false values embedded in the actor that is representing who's playing, and pass using a setter or getter, it's going to be a setter, isn't it, to change the values to true and false as the keys are pressed and unpressed, then that's much better. And particularly with C++, given the speed that these things update, it becomes unwieldy if you don't do it that way. Also, surprisingly, it makes it really easy to connect it to an AI, because you just turn those booleans for the inputs and keys into booleans that the AI controls, and using some sort of sigmoid or some sort of function. Now, we say everything in your game can be thought of as an object, and this can be surprising things like the camera angle and things like that. Now, objects which you set and leave in place are called static objects, but often we will still think of events and triggers that have to do with those other objects. So in the book Game Programming Patterns by Robert Nystrom, he talks about the observer class. And if you went and looked at Unity or Java, they have events built into the programming language by default to handle this concept, though you have to build one yourself if you're doing it in C++, and probably something similar in Python. So an observer class would, the different objects would connect to it, be added to a vertex of or a map saying what they're interested in, and upon the event being registered by calling a function to the observer class, it would fire off a bunch of informing of the things which have set themselves up to receive that information as a potentially interesting it's probably not interesting, but there's a difference between events and observers in the sense that an event is an object created and stored somewhere else for others to look at. An observer is something that is observing the other objects and recording as they happen. And it's probably a very academic point, but it's something that Robert Nystrom makes. So get that book if you're interested in it more. The first way of handling actors is to talk about polymorphism. So you're going to create a class called actor or whatever your base is, and you're going to inherit from that class to create subclasses which use most of the function, most of the parts of the previous code, but add in little bits. So in the below code, the class actor has a virtual void set up for update, and then that is overridden in the class Pacman that inherits from actor. So Pacman is an actor and a Pacman, but as shown in this graph, Spectre might inherit from actor and is also an actor. So Pac-Man and Spectre are actors, but then they're different. They're subclasses. And then Clyde, Pinky, Inky, and Blinky are subclasses of Spectre. And if you know anything about object-oriented programming, you're probably well aware of this. I do believe in C++, because it's compiled. It doesn't have some of the issues that Python has with inheritance and is a bit more slicker, but there is an overhead, and my understanding is for any form of polymorphism, but less so than components, which we'll get onto a second. So when you're creating your game loop, I used to have my first few times of doing this, I always had the main loop in main. I didn't instigate a class called engine or game or manager which represented the world. It's good practice, and it's good practice for surprising point, because you can pass the game or the engine down into each of these actors who can store them as a reference, and they can call back to the main game world various functions. Now that sounds very complicated and maybe silly so, until you realise if your object in the game world was a spawner, say a Minecraft spawner block, it can't spawn something if it can't contact the world that it exists in and communicate to that world, I've created a new thing, here you go. So if you want this sort of complexity, you need to pass into your actor objects a reference to something that manages them, which can then do something with what it calls it back to them. And this is where you then might get a component-based methodology. So the previous one, we created a class called actor, and that class called actor managed that object within C++. For something in Unity, they do this a lot where it's components. Everything is a component. There is a couple of calls to an engine, and each of those different calls to the engine does a different thing, and each of those calls will cycle through all the components in the list and update each single one. Now, Pinky and Pac-Man are objects, but they become a stack of components. So Pac-Man's sprite is a component in this idea, and Pac-Man's position is a different component, and they might all be tracked in one list, but they're all then made accessible by being able to contact the main game world and add them as references into the parent managers, which will cycle through all the parts and update them all at the same time. Now, this comes with some little overhead because there is a very small overhead in C++ or any programming language when you make a call to another function over just doing the code. In C++ you could do some inlining, but that's not going to be possible using this component-based method where each of these little components is their own little object. So this is, the example actor class I've written. You have a class called actor, and the idea here is to make use of both polymorphism and the component method. So you would be taking this class and writing other subclasses which inherit from it and override the virtual functions of its destructor, because when it dies you might want to do something, or the update actor, which you might want to add in some special effects. Though you do have the option of adding components to this component list, which you can see at the bottom here as a vector, and every frame you will call update actor, which will do the standard things for an actor, updating where it is on the screen and printing it to screen, and then cycle through its list of components, which could include calls to the game world, which you can see here is passed in as a class called game, and given as a reference. So why do this? If you did it purely by polymorphism, you could get some very deep hierarchies of polymorphism. As you saw before, actor Pac-Man was an actor and Pac-Man. Each of the ghosts were inheriting from two subclasses down. You can only imagine how complicated it gets in modern computer games, where a given enemy might be a class of a class of a class of a class. It just gets deeper and deeper. So doing this hybrid method of having it as a class that can be added components to do the various things is probably useful, and something that really changed my way of thinking, because I've been writing a computer game about corporations, and I had a moment where I just went, oh, I could do this, and I could add special effects and things by having this component concept that you could add in, and rather than trying to manage all the possible methods that you could need, you can create this system where it updates for the generic behaviors you want for that actor, that in this case corporation, and then cycles through all its components, and the components could be stuff you want to add in to differentiate one special actor versus another. So that's my take on it, and that's my video on C++ coding for actors. I hope it's useful. Thanks, have a good day. Bye.